Okay, here we go with part 2 on weather, and we're going to talk today about wind. In fact, wind is such a big factor, we're going to talk about it in 2 different parts. So there's going to be wind part 1, wind part 2. This is wind part 1. Can I encourage you to put on your thinking caps? Do everything you can to make sure that you really watch this video. I've mentioned before you can put it on a faster speed. I've heard some students say that they transfer it from their computer to their TV, and that's a lot easier to watch it on a bigger screen. Do whatever you can. Make sure you're focusing and you're listening to this, because this is one of the most important lectures in this whole class. This one and part 2. Wind has the greatest impact on fire behavior of any of the weather factors. And we've already mentioned that weather is the biggest of the top 3 factors of fuel, topography, and weather. Weather is number 1. So this is number 1 of number 1. This is like the Kobe Bryant of the old Lakers, right? This is the number 1 influencer of how the game's going to go. Wind is the primary factor that influences the direction and speed of fire spread. Okay, I accidentally hit pause, but we're going to get going here. So, wind supplies, not only does it push the fire, but it supplies oxygen. It bends the flames and causes flying, burning material to ignite spot fires. The stronger the wind, the faster the spread of the fire. So topography is one of your top influencers of direction of fire spread, but the one thing that tops topography is wind. So the 2 together are huge. We call that alignment. When wind and topography are in the advantage of the fire, you want to get out of the way. So let's keep going. What's the definition of wind? Well, it's very simple. It's the horizontal movement of air. The horizontal movement of air. There are a lot of things that factor into why it goes the direction it does. We're going to talk about that. But before we do, let's look at there's 4 types of wind. So the 4 types are there's general winds, which affect large areas. Okay, so these are, we know that in Southern California, the normal wind direction every day is going to be from basically west to east, but it's actually southwest to northeast. That's, common because of the rotation of the earth and because of other factors we're going to talk about later. Then there's local winds, which are produced by the features of the local terrain and the weather patterns. We live most of us in Southern California, and there is a very big factor of we've got an ocean, we've got a narrow, sometimes like places like Santa Barbara, very narrow coastal plain, and steep mountains. These local terrain factors influence the weather patterns. And then we've got surface winds, and those are those winds that are normally measured at 20 feet above the ground. Again, we'll talk more about that later. Mid-flame winds. Now, this is the type of wind. This is where the rubber meets the road. It occurs at the midpoint of the flame height. They have the greatest effect on the direction a fire will burn. They're our number 1 concern, but we need to pay attention to those winds that are higher than us as well. And those of you who've been on a fire crew know that we oftentimes will use a balloon or other ways to measure the wind at the different heights of elevation, because that helps us predict what's happening later on. So let's talk about, first of all, well, here's a little diagram of those 4 different kinds. So the general winds are larger scale, and they're going on an upper level. And oftentimes we can see the clouds are going in a totally opposite direction of what wind we're feeling on the ground. Wind might be on the ground going out of the southwest into the northeast, and then we look up at the clouds and they're going out towards the ocean. That's weird. That's opposite of what you would think, but general winds can be different than what's going on down at the ground. So local winds are smaller scale, they're lower level. The surface winds are what we measure at 20 feet, and then the mid-flame winds are what's right near the ground and are hitting our fire. So a mid-flame wind is greatly illustrated here in this picture. You can see that the wind is pushing it away from this firefighter who's doing a burning out operation. So mid-flame wind is pushing the fire from left to right. Now, winds affect wildland fire spread by, and I kind of mentioned this earlier, supplying oxygen and aiding in combustion, driving the heat into the adjacent fuels, hastening the drying process. They also influence the direction of spread and spotting, right? They carry those burning embers into the new fuels. And this can happen in different directions because of the way that the convective heat brings those burning embers up into the air, and some of them go further than others, and they might get into those portions that go a different direction than what we're feeling on the ground. So that can be a concern. We'll see that in a second. Bending flames closer to the unburned fuels. So because instead of the flame going straight up, it's bending, it's closer to the fuels, preheats it, dries it, ignites it. And lastly, carrying away moist air, replacing it with drier air. So let's talk about wind indicators. Strong surface winds. We know that when we have strong surface winds, we're going to have great speed, and we know the direction that the fire is going to go. This is a great picture here showing the, a day that's probably a Santa Ana-like condition wherever this is, but you can see wind is very strong, pushing this fire forward, and notice how the fire is going to get a V effect, a narrower V effect when you have really strong winds, because it's going to go with the wind more that's going to go out on the flanks. So strong surface winds can even override topography. You can, when fire comes to our mountain communities, or the urban interface, those communities that are like where I grew up, La Cañada, La Crescenta, Pasadena, Fillmore, Ojai. Normally if a fire is coming down towards the ocean and coming downhill, well, a fire backing down a hill is not as great a concern to us, unless it's a Santa Ana day. So that fire is going to go downhill much faster than it normally would under normal conditions. So strong surface winds can override topography in determining the direction and rate of spread. High, fast-moving clouds. Well, what do we know with high, fast-moving clouds? It means a potential for wind shifts, particularly if they're in a different direction. So this is a great picture of showing how up here you can see that the wind is really blowing out this pyrocumulus formation, this fire-dominated cumulo formation of clouds. So notice it's going with the wind, but then, man, it gets up to where the higher, fast-moving clouds aloft are blowing it way out there. Now, that's pretty normal because it's all going in the same direction. But in our next picture, we see a situation where the wind at the surface winds, are different than the aloft winds. So this is a great concern. Winds from different directions can cause spot fires on our flanks. So notice, prepare for some serious spotting along the flanks. We might get embers, so convective heat and the wind push those embers. They go up with the heat, but then the wind pushes it a different direction, and eventually gravity causes them to fall, and you might have spot fires out here on your flanks. You got to watch for that, and that may be, notice that this fire is like this, but then way out here, see that? That is an indicator that this flank caught fire again, because of that action. So notice that it can be in a different direction because of high winds aloft. Not always, but an indicator, something we got to be concerned about. Approaching cold front. Now, this is a huge thing. We're going to talk about it quite often throughout the whole weather discussion. And when we have a cold front, winds can turn 180 degrees in difference rapidly. So winds will shift and increase as the cold front approaches and moves by. Sometimes they come and they go really fast, but all of a sudden you'll have wind changes, you'll have downdrafts, and this is what happened in Yarnell Hill. So this is one of the last photographs that were taken of the Granite Mountain hotshots before they were killed by this fire. And notice that the fire has changed directions, or is at least starting to in this photograph. It was going away from them, and then it started coming back down this area. So they knew that. They saw it. But they, what they didn't know, that after they lost sight of it, I mentioned this earlier in a previous lecture on safety, that after they started going down the hill and they couldn't see the fire anymore, it increased in speed. As the cold front got closer, and this is a great picture of a cold front, they're very impressive. Any of you who've traveled in the Midwest and have seen these kind of, and Arizona gets what do they call that? The monsoon season, and they get these amazing cold front clouds and things. So we need to be aware of that. What happened here, though, was as the cold front got closer, the speed increased, and that's what caught them by surprise. So cold fronts can cause, this is I believe a test question. Remember, cold fronts can cause 180 degree wind change and increase in rate of spread. So you got to be aware of that. Two famous fires where firefighters died, South Canyon Fire and Yarnell Hill. Both of them, the number one factor that influenced their deaths was an approaching cold front. One they weren't as aware of, the other one they were aware of, but they underestimated. Don't underestimate a cold front. Then cumulonimbus development, which is related to cold fronts, often have a cumulonimbus development, but cumulonimbus developments aren't necessarily related to cold fronts. They can be. Okay, cold fronts can have usually will have a cumulonimbus development, but we also see them in other places. We're going to spend a lot more time talking about this, how it happens when we talk about clouds and air stability. But I just want you to notice, isn't this a beautiful, impressive picture? But this underneath, the cumulonimbus development. So when we're talking about thunderclouds is the other name, or lightning clouds, lightning storm. You'll often hear these referred to in the month of August, like we've been experiencing. You see these off over the mountains and something like that, where heat is rising, and as the heat rises, it hits the cold air, and moisture develops, and you get this beautiful thunderhead type of development. Well, as the day wears on, the amount of moisture and energy in there is just enormous, and eventually the moisture gets heavier than the air, and the cold air then with the moisture starts dropping down. Now, this isn't rain necessarily. It might be rain, but we call this virga, V-I-R-G-A, virga. And virga is moisture, cold usually, moisture that's dropping out of a cumulonimbus cloud going towards the earth, and what it carries with it is cold air and therefore wind. Around a cumulonimbus storm with downdrafts. Downdrafts are huge. This is the number one most concerning thing with cumulonimbus development is downdrafts, not lightning, downdrafts. The downdraft, then when it hits the ground, goes every direction. So you can have winds that go 4 different directions at once when you get a downdraft from a cumulonimbus development. This can have an enormous effect on a fire. All of a sudden, wind is going 4 directions if you're directly underneath it. So I knew a guy, a crew member who was with LA County Fire with a inmate crew, was on a fire out in the Antelope Valley, and they had a storm front coming on towards them, and they knew it, and the wind was coming off of it and pushing the fire mostly in one direction, and it started to increase, and he called out for his whole crew to go into the black, and they went into the black, and this thunderstorm went right over them. And he said he saw something he's never seen before, and all of a sudden the fire went 4 directions at once. The wind literally was going 4 directions, north, south, east, west, and the fire went each direction. If they weren't in the black, they could have easily got burned over, and they were safe in the black, but he said it was an amazing thing to see and watch. So that's rare, but that can happen under a thunderstorm. And our last big wind indicator that's in this portion is battling or opposing winds, and we will talk about those more when we talk about foehn winds in part 2. So what we have to understand is where the winds come from. Now, we talked about that heat balance and the lag time and what's going on the earth throughout the day. The heating and cooling of the earth every day is what influences air movement. So what we get is high and low pressure systems. Now, the winds, like everything else in weather, have their origin in the sun. As the solar radiation hits the Earth's surface, the Earth doesn't heat in a uniform way. There's cold parts in the tops and bottoms. There's hot parts in the middle. And because of this, we have uneven heating. Then this creates atmospheric pressure differences. Hot air and cold air pockets. So the hot air that's rising is high pressure, and the low pressures are related to cold air. So we call these pressure gradients. Winds are produced as air from a high pressure area moves towards a low pressure area. The greater the difference between the pressure areas, the stronger the winds can be. And when we talk about foehn winds, we'll see that we get Santa Ana winds when we have a high pressure that's over Utah and the Great Basin area pushing up against the Rockies, and then we have a low pressure that's down over Baja or off of the Pacific coast, and the air moves from the high pressure to the low pressure, and that great difference between them, also with gravity winds, they call it katabatic air, is going down from the Rockies down towards the low pressure off of the coast. It increases in speed, and it also increases in temperature, and the humidity goes down, the heat goes up because of friction and because of dropping down. So we'll talk about that more later. So pressure gradients. Well, we see in this picture the highs, and they would be related to or seen, this would be warm temperature, and then lows where there's cooler temperature. So they're moving around, and they call these pressure gradients. Now, they refer to troughs and ridges, and we'll talk about that in a second. But the highs and lows are a product of that uneven heating of the Earth's surface. Equatorial air moving up, and desert air that moves up, in different parts of the Earth. And so we have these differences in solar heating. We also have the rotation of the Earth that influences those pressure pockets, and we also have gravity. All of these things influence which ways and the behavior of the direction and rate and behavior of the winds. So we have some general wind circulations, and sailors are very alert to this, where there are predominant winds. The old, when you think about it, these old sailors that came all the way from Europe to the Americas and how they got here, it's pretty amazing when you think about it. But as the warm air from the equator rises and the cooler air from the polar regions move into the void, we have this, along with the Earth's rotation, we have this constant state of motion. So where do our Southern California storms usually come from? Take a second and think about that. When we get two kinds of storms. We get those El Nino Pacific types of storms that are a little warmer and very wet. And where do they come from? They come off of the Pacific Ocean. And then when we're lucky, we also get some of those Arctic storms that come down from Alaska, and they come in a northwest to southeast direction. And sometimes Washington and Oregon and Northern California get all of it, and we don't get enough of the rain or snow associated with that. But those are the directions our storms come from. So, and they come off of the Pacific, whether it's northwest or southwest or just direct west, and then they go to the east. Well, that has to do with the Earth's rotation. It has to do with those pressure gradients. So wind speed is determined by the pressure gradient, the difference between the highs and the low. The greater the distance, the greater the speed. The wind direction is determined by all of those relationships of the highs and lows and the gravity of the Earth and all of that. So what happens is we get cold fronts and hot fronts. But when cold air is displacing the warm air, we call it a cold front. It's the cold air is pushing and is moving the warm air away. So these are the leading edge boundaries of these storms. We call them fronts. When the warm air is pushing the cool air away, we call that a warm front. So when warm air goes over cold air, see, that's opposite of normal, right? Warm air, when a warm air mass rides up and over a cold air mass, we call that an occluded front. So the hot air is holding the cold air down. But as you go up in elevation, what is normal? The air gets colder. As you go up in the mountains, you notice that as you go up in elevation, that little temperature thing on maybe it's on your mirror or wherever it is on your dashboard, you start seeing that number go down as you go up in elevation. Well, when we have an occluded front, we have the opposite. The hot air is on top of the cold air, and that's an occluded front. So these are called troughs and ridges. So the area of low pressure is called a trough. So just think about it. If you're a horse and you want to drink out of a trough, you're going low. And the mountains, what's the highest part of a mountain is the ridge. So the ridges are high. So that's the way to remember it. This is meteorologists talk. They talk about troughs and ridges. They're just referring to a trough is low pressure, and a ridge is high pressure. Now, they have descending air and a minimum of cloudiness and precipitation, whereas low pressure is usually related to storms. So we like it in Southern California when we get a low pressure in here. Our normal is high pressure. You look at the maps, and more often than not, there's a high somewhere in California, and that makes the storms that come from Alaska sometimes go around us. The pressure is higher along the ridge than on either side. So there's seasonal patterns that are considered the norm, but of course they can be broken, and that is our current drought. We're not as bad, but we are in a long-term drought that's been going on since the 1960s, 1970s, off and on. It's more drought than normal. Okay, so let's get talking. We've talked about those general winds and what's going on. Now let's talk about Southern California and local winds. Sea breezes, land breezes, slope valley winds are all considered local winds. So they happen in a small scale caused by our local temperature differences, by our local topography, and they are just as important, and in fact, in Southern California, very important to firefighters as those general winds. Local and general winds are going to, of course, be related. The local winds are going to be influenced by the general winds, but because of our local factors, we have much more in Southern California than in some other places. Our fires are oftentimes dominated by these local factors and the time of day and the time of year. And we refer to these as diurnal winds because they're influenced by the sun going up and the sun going down. So diurnal winds is another term for local winds. So in Southern California, as I mentioned, the ocean, the coastal plain, and the mountains are going to dominate our wind behavior. And the winds usually begin somewhere around 9 and 10 in the mid-morning as the sun warms the land and you've got that cool air off of the water, and now the land starts to warm up and it becomes warmer than the water. So the hot air rises from the land and it draws cooler air from the sea on shore. So I'm making this recording at about 9 o'clock, and I'm looking at the trees around me and there's no movement. But somewhere between now and 10, maybe 11, and I can feel the sun is starting to warm the air around me. It's late August. It's going to get hot today. And in the next hour, we will see, and especially down there in Ventura County and up the Santa Clara Riverbed area, from Santa Paula to Fillmore, you'll start to see these winds start coming in. And as the land and the air warm, the air rises, draws the cooler air from the sea onshore. So these sea breezes are generally cooler with higher humidity, but as the day wears on, the humidity will go down and that air is going to come in and it's going to increase in speed as the day goes on. Then the opposite is going to occur at night. As the land cools, then that cooler air is going to drop down, and those winds that were coming in are now going to turn around in the evening and start going back out towards the water. Now, not at the same velocity. The winds in the evening are going to be cooler and are going to be slower than the winds during the day. Okay, I got to keep moving. The rule of the thumb. So here's how you remember it. As the sun rises, so do the winds. Sun up, winds up. Up canyon, up valley, up mountain. As the sun goes down, now we've got the reverse. Sun going down, winds go down towards the ocean. Here in Southern California, this is an absolute rule of thumb unless the general wind factors, in other words, Santa Ana conditions or sundowner conditions, change that. Okay? Those are the exceptions. Here in SoCal, the wind comes out of the southwest and goes towards the northeast. So, daytime from sea to land, nighttime from land to sea. Okay? So these local or general winds are going to push the fire from right to left in this photograph. It's predictable. Okay? And this, we'll talk about battling winds, but this is really important on the last days of Santa Ana conditions. So we need to know that there are different ways that this plays out depending on the topography. So we know sun goes up, wind's going to go up, it's going to come inland. But slope and valley winds are also diurnal. So in a canyon like Yosemite, or up in the Angeles Crest area, or other big or in the San Joaquin Valley, we're also going to have diurnal or daily winds that are produced as the surface of the earth heats or cools. They flow upslope during the day. But what's different, the narrower the valley, what do we call a narrow valley? We call that a canyon. okay? The warming of the ground is going to happen later in the day because it's shaded from the steep slopes. So they're still going to flow upslope during the day as they are warmed, and downslope during night as they cool. But there's going to be a slower aspect to it. It might happen later in the day. So relatively calm periods can exist, and this happens here. Like I'm saying, it's morning, and I am actually, it's kind of funny. In the little bit of time since I said that, I'm looking at now the leaves, and they're starting to move. So it's I forget what time it is. It's about 9:15, 9:30, and it's starting to happen. Same thing at night. All of a sudden, a breezy day, a strong wind, around 6, 7, as the sun's going down, you start to see a lull. And it's lulls you need to pay attention to. Don't say, oh, the wind stopped, we're safe now. No, it's going to eventually change direction. So downslope winds are usually gentle. They're slower, like I said, 2 to 5 miles per hour, but not as velocity, but the upslope can be, normal around my home is 5 to 10 miles per hour, and sometimes gets to 20 or 25. But the principal force behind downslope winds is gravity. Cold air goes down. It's heavier. So, like slope winds, valley winds are also created by that solar heating. The valley winds are going to be, as I was just saying, slower to develop. They'll be late morning or very early afternoon, depending on the width and the size of the valley. A tighter canyon doesn't heat up until later in the day. So large valleys like the San Joaquin Valley, they're going to be pretty close to what's happening on the coast. They're going to start much earlier, but you're still going to get an upward motion. As the sun goes up, the winds go up. Upvalley winds are stronger than upslope winds, ranging from 10 to 15 miles per hour. So normal, this is normal every day in Southern California, other than when we have Santa Ana conditions. Upslope, up valley, but notice that it's going in slightly different directions. So topography has an effect on the direction of the wind as well. And then as the night wears on, the winds go down. They might be significantly 5 to 10 miles per hour and 10 to 15 during the day. Around here where I live in Santa Clarita, even 10 to 20. So upslope versus up valley. The main difference is upslope winds and up valley winds is that the up valley winds do not start until most of the air in the valley is warmed. Upslope, which is all along the Southern California coast and mountains, these slope and valley winds, they don't always happen on all slopes, and they don't happen in all valleys at the same time with the same speed. It all depends. So that Santa Clara River bed area, as you go from Santa Paula to Fillmore to my house, there are different factors influencing because of that valley that are different than Santa Barbara or Malibu or LA. So the aspect is also a primary factor driving these differences because of the solar heating that's happening on the earth. So I grew up in La Cañada, La Crescenta. It's very different there than where I live now in Santa Clarita. It's very steep there, and they do get stronger winds than we get here in Santa Clarita, but we get more heat. In fact, I always used to say at my home here in Santa Clarita versus my family that stayed in La Crescenta, I said, hey, when it's hot, it's 10 degrees hotter here. When it's cold, it's 10 degrees colder here. It's more extreme because we're kind of high desert here. So notice that here's an upslope wind that's influencing this fire. You've got to be aware of that. You do not want to be above this fire when you have an upslope wind that's now also the topography of the slope influences this fire going faster uphill, and now you've got wind behind it. This is a big deal. We're almost done here. Upslope wind and topography are causing the fire to move upslope rapidly. Don't underestimate how fast valley winds and upslope winds can have on fire behavior, because you've got two major alignment factors. The slope is in the advantage of the fire, and the wind is in the advantage of the fire. Now, two last slides here. The effective topography on wind. So remember that not just that normal wind direction, but the topography funnels the wind in different directions. It wants to go up valleys, it wants to go up canyons, it wants to go up slope. So they can cause the wind to do a lot of weird things. They can cause whirlwinds where you have conflicting winds. The wind is going in a predominant, if you go up higher, into those surface winds or upper topography. Above the topography, the winds are going in one direction, but then the topography is funneling it and channeling it, and now all of a sudden you have two winds that are hitting each other because of a valley hits a canyon, and you've got river movement, and you've got all of these different factors, and you can have wind within a very small direction create whirlwinds. Now this happens at my house all the time during the fall when the leaves are falling and the winds are increasing in behavior. We get, I live where two roads meet. There's a T, and it's actually two kind of not truly canyons, but two drainage areas meet. So the wind spins right out in front of my house. It comes down one street, it hits the T, and then the other wind is coming down in a different direction, and it creates a whirlwind. So if I forget and leave my garage open, every leaf in Santa Clarita ends up in my garage because of this whirlwind. All of a sudden, it's just coming around, and I've watched it go down the street, come up my little cul-de-sac, go up my driveway, and right into my garage. It's a conspiracy by the world against me to mess up my garage. So we call these eddies and whirlwinds. So it forms eddies when crossing ridges or canyon intersections. So last little slide here. I'm sorry, this one was way longer than I wanted it to be, but it's important material. Look at how topography can affect the wind in so many different directions. Isn't that amazing? The wind is blowing this way, but because of these valleys and ridges and chimneys and all of these different things, the wind goes all these different directions. Okay, that's the end. Take a break and then watch part 2.